Okay, all right. Actually, last week only we have started our all academic lectures, but in last week, the 3 lectures of SDD1 were engaged by Dr. Preeti Kulkarni ma'am, as you needed the bridge course for understanding the basic concepts of planning, building planning. I requested Preeti ma'am to engage those lectures, and accordingly she conducted the 3 lectures, and I hope everybody, all of you have now aware of the basic concepts of building planning. Am I right? Am I audible? Students?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay,
Yes, ma'am.
okay, all right. All right. Now let us start with the first unit today, that is Introduction to Reinforced Concrete. I have purposely added the contents of first unit as well as the second unit on next slide, because as you see, the contents involved in unit number 1 and 2, they are linked with each other. They are connected with each other, and I'm not going to teach you as the sequence mentioned in your syllabus. So as per the syllabus, the contents of first unit are, in the first part, there is introduction to RC, or composite action, then what is the role of structural designer, then structural properties of concrete and steel, behavior of concrete under compression and tension, behavior of steel under tension, and design philosophies. Second part consists of classification of limit states, characteristic strains, loads, partial safety factors, then analysis of RC structure or RC section under flexure, the assumptions and stress strain variations across the section, then behavior of RC section under flexure, how we define under reinforced, balance and over reinforced section, then the design parameters for rectangular section and how to calculate the moment of resistance for rectangular section, singly reinforced section, doubly and flange sections. These are the contents of unit 1. And unit 2 consists of the basic concepts of load and load combinations, stability of a structure and code provisions, limit state of serviceability, what are the provisions by IS code, and part 2 entirely deals with the design of flexural member, that is design of beams. So what will be my flow? I'm going to start with unit 1 with first part. Then I'm going to cover the unit 2 first part, because both these parts are actually related with the introduction to the subject as well as introduction to the limit state method. Once we cover the entire introduction part, then we can easily go to the analysis and design part, which will be having a continuation. So this will be the flow for only unit or the initial lectures, that I will cover some part 1 of unit 1, and then I will go to part 1 of unit 2, and then again I will go to part 2 of unit 1 and part 2 of unit 2. Okay. So let us start with the part 1 of unit 1. To start with, actually you are studying the design based subject for the very first time. So you must understand what is the meaning of engineering structure and what is structural design. So here are the two definitions which I have written here. First is an engineering structure. It is defined as an assembly of members or elements transferring load or resisting the external actions and providing a form, space, and enclosure and or a cover to serve the desired function. So this is a very simple definition of engineering structure, that it is the assembly or combination of the various members or elements which will transfer the load or resist the load. Now resist the load means whatever the load acting on these elements or members, the members should be able to sustain that load without showing any failure. I'm going directly to the failure term, but without showing any excessive deformations. The members or the elements of the structure should be strong enough to sustain that load, and they should be able to transfer the load also safely to the another connecting members. So can I ask you one question? Anybody can give the answer. What are the different elements of any structure? See, we are dealing with a reinforced concrete structure. So let us consider the example of a residential building. everybody, we all are staying in our own house. So just by observing the various components of the house, can you tell me the names of various members of structure?
Columns, beams, slab,
Correct.
foundation.
Correct, correct. So beams, slabs, columns, foundations, these are the very basic components of the structure, and all these components or elements are connected with each other so that the load coming on the entire structure will be transferred from all these members to the another connected member. For example, the load coming on the slab, it will get transferred to beam, then from beams to it will get transferred to the columns, from columns to the footings, and from footing finally to the finally to the surface beneath the structure or a soil or a ground. Okay, so this transfer of load should be safe without disturbing the stability of the structure. Okay, so this is how we define the engineering structure. And the another function, what is the main function of the structure? Why we are erecting a function structure? There is a certain function for every specific structure. It is actually providing us a space, a covered space, which can serve for the desired functions. If you are erecting a residential building, the rooms should be utilized for the design function, or the entire college building, or say school building, or offices, whatever the function we are expecting from that particular structure, that desired function should be properly served by that particular structure. So this is how we define the engineering structure. Now, how we can define the structural design? It is, I'm just reading the sentences or what is the definition written on the slide here. Through this definition, you will understand how we are defining the structural design. So structural design is a science and art of designing with economy and elegance a durable structure which can safely carry the design forces and can serve the desired function satisfactorily in working environment during its intended service lifespan. So it's a big definition, but if you read it carefully, you will come to know that actually this definition is indicating all the basic requirements for the design of any particular structure. So what is structural design? It is a science. Obviously, it is a science. Whatever the fundamental concepts of science we are learning, we are going to apply it in the design. So it is a science and art of designing. Now, when we design any particular structure, we just don't design like a rectangular plan or a square plan. We try to give some aesthetical view to a structure, and accordingly we make the changes in the design. Basically, it comes in the planning stage itself, but whatever the plan you prepare, accordingly we have to make certain changes in the design steps also. So it is the art of designing with economy and elegance. Obviously, when we complete the design of any particular structure, we have to decide what will be the cost required for the construction, and again what will be the cost for the maintenance of the entire structure. So by considering the total cost involved in an entire project, we have to design a particular structure. And elegance means obviously whenever our structure will get erected, how it will look, whether it is attractive, aesthetically attractive. The people should look at our building and should wish to come inside that building. Oh, very nice building, let us go inside and see how it is there in from the interior part. So there should be certain elegance involved in the design. It should be a durable structure. Now, can you define durability, or what do you understand by durable? The word durable. Hello?
Long lasting.
Long lasting. Okay, okay, long lasting. Fine. It is a very short definition of the term durable, but actually it is the true or the correct definition. It should be long lasting, means whatever may be the environmental conditions. See, in India, we are enjoying three different seasons: summer, rainy season, and winter. In all these three seasons, over a period of time, your structure should withstand all the loads. It should not show any failure or any damages to the structure when the season changes. Okay, so it should be durable, and long lasting means for whatever the number of years we have designed the structure, for all that entire lifespan of the structure, it should remain in a durable condition. Okay, so a durable structure which can safely carry the design forces. Again, the way how we have defined the term engineering structure, that all the members of a particular structure should carry the force safely and should transfer the force to the next connecting member and can serve the desired function satisfactorily. If we are constructed a building for residential purpose, it should serve that desired function. If you have constructed a particular building for say mall or a say stadium, so it should serve that desired function satisfactorily. In working environment, again, it is related with the term durability. In working environment, whatever is the environmental condition, exterior environmental condition, your structure should be safe, should safely perform its function during its intended service lifespan. So normally when we design any particular structure, the design or the lifespan of the structure is considered as 50 years to 100 years. For the most important structures like hospitals or college buildings or school buildings or say nuclear power plants, all these structures are designed for 100 years lifespan. Other buildings like residential buildings, etc., they are designed for 50 years lifespan. Certain temporary structures also we design. These are normally designed for 5 years lifespan. So depending upon the purpose for which we are erecting a particular structure, what is the function, expected function of the structure, depending upon that we have to decide the lifespan. And whatever the lifespan for which we decide, the structures would withstand for that entire lifespan without causing any trouble to the users. So this is the overall definition of the term structural design, that it is a science and art of designing with economy and elegance a durable structure which can safely carry the design forces and can serve the desired function satisfactorily in working environment during its intended service lifespan. So if you again read this particular definition, again I will repeat that there are the terms which are actually indicating the basic requirements of structural design in this particular definition. So let us move to those terms now. You'll understand once we go one by one to all these basic requirements or objectives of a structural design. The first and most important basic requirement or the objective of structural design is safety. It is of prime importance. Whatever the structure you design, it should be safe first, so that or then and then only we will be able to use that structure. Otherwise no one will enter in that structure. If you have a feeling of that, okay, this particular structure is not safe for utility, no one will enter inside that structure. So safety is the most and prime important requirement of any structural design. Now the safety, how we can achieve, it is normally achieved by providing adequate strength and stability. Adequate strain means each and every member of a structure, it should be strong enough to sustain the load or the external forces, whatever acting on that particular structure. And at the same time, it should be stable. Means when any particular structure is subjected to external loading, the equilibrium between all members should not be lost. Okay, the entire structure should be stable while transferring the load from one particular member to the another member. So safety is achieved by adequate strength and stability. But along with safety, there is one more term which is nowadays very important, and that is called as ductility. We are talking about now RC structure. RC means reinforced concrete. Okay, so we are actually dealing with two different materials. One is the concrete and second is steel. Now in your second year course, you have learned both these materials separately. Am I right? You have learned concrete separately under the subject, I think, material testing and evaluation. Am I right?
Yes, ma'am.
Yes, ma'am.
And the second material, that is steel, you have learned under MOS 1, Mechanics of Structure 1. So you have conducted certain practicals on steel.
Yes.
So you have learned the behavior of both these materials separately. How the concrete will behave when we subject some loading on that, and how the steel will behave when we subject it to a certain external action. But here now we are talking about the reinforced concrete. So it is a combination of these two materials. There is concrete as well as steel. And you are well aware that both these materials are exactly in opposite nature. If you consider the properties of these two materials, concrete is a heterogeneous, brittle material. It is anisotropic. Whereas if you consider steel, steel is completely homogeneous, ductile material, and it is isotropic. So the properties shown by both these materials are exactly opposite in nature, and now we are combining together both these materials and trying to use a composite material with the expectation that there will be the composite action of both these materials. Okay, so when we deal with such composite materials, we have to consider the properties or effect of properties of both the materials together. If we consider only the concrete, we all know that concrete is a brittle material. There is no ductility. So if you put a concrete, or rather, I'm going to ask you a question. Can we put a concrete in the UTM and apply a tensile load, axial tension? Is it possible? We are making, say, suppose we are casting a concrete beam and having a circular shape, cross-sectional, and we will put it in UTM and we apply axial tension to that particular beam. Is it possible?
No, ma'am.
No.
No,
Why
ma'am.
it is not possible?
Ma'am,
Because
Concrete
it is a
behaves in a
brittle material.
compressive manner.
Yeah, concrete is very good in carrying compression and it is very poor in carrying tension. Okay. And the another important thing that it is completely a brittle material. So if you apply a little tensile force to that particular material, it will fail immediately. So there is no any ductility in that particular material. But the same if we think about steel, steel is completely ductile. Okay, so how will we achieve ductility in RC structure? This is the most important thing. Or rather, I would say that in a concrete structure, if we, any particular structure, if you construct using only concrete, you will not be able to get ductility in that structure. And to achieve, to get certain ductility, we have to reinforce steel into the concrete and we then cast the reinforced concrete structures. This is why we are using steel in the concrete, because we want a certain ductility. Now, why the ductility is important? Why we need ductility? Yes? See, you have,
Ma'am,
yes?
at the time of earthquake or something, tension might create, so ductility is important.
Yes, tension might be. See, whether it is earthquake or whether it is a wind load, excessive wind load, any sort of lateral load when it is acting on a structure, tension is going to create. Even when a transverse force is acting on a building, a vertical load is acting on a beam, there is a tension in the bottom side of the beam. So every member, it is always subjected to tension, some sort of a tensile force. So without having a sudden failure, there should be a certain prior warning before collapse. That is the need for the ductility. I will explain you in detail with the example of steel tension test. You have performed the tension test on steel in MOS 1 practicals, right?
Yes, ma'am.
Yes, ma'am.
So when we perform the tension test on the steel, what happens? We apply axial tension on the steel rod and we start pulling the rod. Initially, the rod will elongate. It will go on elongating. A neck will form and then it will fail. This is how you have studied the stress and behavior or load versus deformation behavior for a steel, right? So steel is a ductile material and it will never show a sudden failure. It will show certain deformation within certain limit first, then the deformation will go on increasing. And when it exceeds the limit, then only the member will fail. Okay, so for in case of ductile material, the failure is not sudden, but it is slowly. And you can observe that yes, the material is getting failed now, and we can get a prior warning before the complete failure or complete collapse of particular member, so that a person or the members who are utilizing that particular structure can escape out from that structure and can save their own lives. Okay, so to avoid the human life, loss of human life, ductility in the structure is necessary. See, when external load is subjected on a structure, the beam or the slabs will definitely bend. But the bending of these members we have kept in a certain limit. We have to keep rather within certain limit. We have to design these members accordingly so that they will not show excessive deflection, excessive deformation. But when the things does not remain in our control and the members start showing excessive deformation, they should not fail suddenly. Rather, they should show the more and more deflection. They will show some cracking so that we get certain indication that, okay, this particular member is going to fail now. We should leave this structure immediately. So it will give us the prior warning before collapse and we can save our life. This is the reason why we need ductility in the structure. And that's why we do not construct only concrete structures, purely concrete structure. The steel is added only for achieving ductility in the structure. So safety, when we go for the structural design, along with safety, safety means we have to provide the adequate strength and stability to the structure along with sufficient ductility in the structure. So these three terms are important when we call a term safety. Second important requirement is serviceability. What is serviceability? See, we have constructed a structure. Hello, are you able to hear me?
Yes, ma'am.
Yes, ma'am.
Okay, so certain sound I heard certain sound, so I thought whether I got disconnected or not. All right. So serviceability means suppose we have constructed a residential building and we have obviously a slab on which we have placed a very nice flooring, and suddenly if due to excessive loading or whatever may be the reason, the slab has started bending, what will happen with the flooring? It will definitely get disturbed, right? All the flooring will get distorted and the purpose for which we are using that particular flooring, it will not be satisfied. Our entire interior furniture, it will get disturbed. If your beam is showing excessive deflection, the connecting other members will also get disconnected or will show the damages heavily. Okay, so serviceability means a structure should serve the intended function and give the satisfactory performance throughout the lifespan. It should be serviceable. If any particular structural member or element show excessive deformation, the serviceability will get disturbed. So your structure will not remain fit for utility. If your flooring will get completely disturbed, if it will get completely disordered, we will not be able to use that particular flooring for any utility. So the serviceability criteria normally depends, or these are normally measured based on the deformations. Now, deformation may be in the form of a deflection, it may be in the form of a cracking, or even it may be in the form of a vibration. Just imagine that you are sitting in a classroom and 4 or 5 students are running in from the corridor portion outside your classroom, and the slabs are designed in such a fashion that only 4 or 5 students are running and the slab is vibrating to a very large amount. Those vibrations, when you are sitting inside the particular room, it will give us a very unsafe psychological feeling. So excessive vibrations have an unsafe feeling, psychological feeling in the mind of users. So this is also the important serviceability criteria, that whenever we design any particular structural member, the vibration effects will also be within the certain limits. Okay, so when we design any particular structure, we have to focus on the serviceability criteria, focusing on its deflection, deformations, cracking, and vibration effects. And that's why there are certain limits we have to put on all these. Whenever we design any particular beam, we have to check its deflection, whether it is within the acceptable limits or not. Whenever we design any particular slab, we have to check its vibration limits, whether it is within the acceptable limits or not. Okay, so this is about the serviceability. Next is durability. As we discussed earlier, that durability means resisting the environmental actions during the anticipated exposure conditions. Now, every region in a particular country has a specific exposure condition. For example, in Pune, it is a moderate exposure condition, but if you consider a exposure condition at Mumbai, it is of severe nature because it is close to the coastal line. Mumbai is along the coastal region, and due to the effect of ocean, the temperature variations are high, humidity conditions are very high. So the overall exposure conditions in Mumbai are severe as compared to Pune. Okay, so every city, every region of every country, we have to consider what is the exposure condition in that particular locality, and accordingly, we have to make changes in our design. Okay, so this is nothing but taking care of the exposure condition means we are actually designing the structure for durability requirements. Okay, this is the another prime requirement, because if we are designing a structure for 50 years, over a 50 years, the exposure condition of a specific location may change. Initially, a particular location shows very high temperature, but over a period of time, the temperature may lower down. So changes in the nature are not in control of human beings. But what is in our control? We can design the structure so that the changes in the nature can be resisted effectively by our design structure. So this is the durability criteria. Now the next is economy. Now if you consider all other parameters like safety, serviceability, durability, even aesthetics, all these parameters are directly linked with economy. If you have money, I can make my structure very elegant. I can give a very aesthetic appearance to my structure by making giving a very nice architectural looks. If I have a sufficient amount of money, I can use the best quality material in my structure to make my entire structure strong and durable. So all these parameters are directly linked with money, economy. So what is the role of the designer now? Does it mean that you should not use the best quality material? Does it mean that you should not try to give a pleasing appearance to your structure? Definitely not. But whatever you are doing, you should to try. You need to try the optimized utilization of all these requirements. So what are the requirements actually? Optimize utilization of the materials. We have to use the best quality of material, but utilization of material should be so optimized that we can achieve certain economy in the utilization of material. The aesthetic looks to the structures should be given in such a fashion that it should look good at the same time we can achieve the economy. Okay, we cannot compromise safety and durability aspects at all whenever we achieve or whenever we do any structural design. But obviously we have to think about the economy also. So economy is related with the optimum utilization of material and its strength, and finally the total cost of construction and maintenance. So when we talk about the total cost of the any particular project, it involves actually the cost at two stages. One is at the construction and another the maintenance cost. See, initially we have used a moderate quality of material and we have achieved economy in the construction, but later on the members, if they start showing deformations, if they start showing cracks, okay, maintenance of the structure will require a huge cost in that case. So while designing, we have to consider the optimum use of material along with keeping in mind the cost requirement for the maintenance also. Okay, so use a good quality of material, but the cost of construction should be within the limit, and the ultimate cost of maintenance should be also within the limit. This is how we can achieve the economy. Next important point is aesthetic. So giving a pleasing appearance without affecting economy. This is again important. I want to give a very pleasing appearance to my structure. I'm designing in such a fashion, but I also don't want to affect the economy. This is very, very tedious job actually. Like giving aesthetics to the structure at the same time achieving economy. But we can do this over a period of time. If you have a sufficient practice of designing the structure, we can incorporate both these, that giving the pleasing appearance as well as achieving the economy also. And the last point is feasibility, practicability, and acceptability. See, one may say that I have a lot of money and I want to give an excellent aesthetic view to my structure. So let us construct my entire house in a say oval shape structure. Is it possible? See, if we have a money, we don't have any restriction on economy. I want a best aesthetic looks, but whether it is practicable, whether we can construct such structure, whether it is practicable, whether it is feasible, whether it is acceptable, all these criteria also we need to check. I will just show you one picture. Tell me what is this? Many of you must be knowing this.
Ambani's bungalow.
Yes, it has some name. You know that?
Antilla
Anant
Tower.
Villa.
Yes.
Antilla.
Pardon, please?
Anant Villa.
No.
Antilla Tower.
Antilla.
Antilla
Right.
Tower.
It is Antilla Tower. So can you see the shape of the structure? It is not exactly rectangular. If you consider the side view, it involves lot many offsets, and it looks like a very asymmetrical structure with some offsets and some zigzag manner flooring, etc. At somewhere it is connected, at somewhere it is not connected. Somewhere you can see the vertical column, somewhere it is V-shaped column. So it is not a symmetrical structure. Obviously, the money involved for construction of this structure is a huge amount. But if you consider the aesthetic view, it is very nice looking structure. Okay, and you can consider the last aspect, that is feasibility. It is feasible. Okay, designing such type of a structure is feasible. So if you consider, if you Google out the construction of this particular structure, you will get a lot of information. So I will not go in the giving information of construction of this specific structure. But when we want to have or want to construct such type of a structure, we truly cannot construct the entire structure simply by using reinforced concrete as a material. There should be a combination of steel as well as RC. Now, the example, if you consider the Antilla Tower, it is a combination of steel as well as RC. If you consider the columns, columns are made with purely steel columns. There is no RC there. Okay, but the slabs, if you consider, they are composite slabs. So whenever we want to construct or want to design any Hatke type structure, in which we want to put the aesthetic views also and the safety also and durability also, we simply cannot think only about the reinforced concrete as a material, but we need to go for the composite structures. Okay, so these are the basic requirements which I wanted to discuss with you. I just want to have a short quiz based on this only. So I'm going to copy this particular link in a chat box and I will give you 5 minutes. Everybody has to go through this particular quiz. Have you got the link?
Yes, ma'am.
Students?
Yes, ma'am.
So I will give you 5 minutes time. You quickly go through this particular quiz. It is a very easy quiz. Once you complete the quiz, you just write down done or submitted in your chat box. I hope whatever I have shown you through this PPT, you have noted down all this in your notebook. Then only you will be able to solve the quiz. Have you submitted? Omkar?
Ma'am, I'm currently giving it.
Okay. It is not very difficult quiz, huh? There are just 5 to 6 questions. So have you submitted it? Students, are you there? Shall I start with the next part? Have you completed the quiz? Yes, Aarti. Are you there, Aarti? Aarti Patil.
Ma'am.
So have you finished with the quiz?
Yes, ma'am.
Also, you write down in chat box, please, done, at least done, submitted something. Those who have completed the quiz, please write down in the chat box that you have done or submitted. Okay, Aarti. Let me know how many questions were there in the quiz. Aarti Patil. Rishikesh.
Ma'am, 5 questions are there.
Okay, okay, okay. What about others? Okay, all right. Okay, shall I proceed with the next part? Okay, all right. Now I will start with the next information. I'm going to share again the screen. All right. Now we have discussed about the basic requirements of structural design. And as we are talking about a reinforced concrete material, we must understand what are the properties of the material as a reinforced concrete. As I have discussed that there are two materials, concrete and steel, and both these materials we are combining together to get reinforced concrete as a material. Okay, so both these materials specific properties are important when the design aspects are considered. So let us see now the various properties of the materials. First, we will start with the properties of concrete. Now, as you all know that concrete is best in carrying the compressive stress or compressive force, whereas the tension carrying capacity of a concrete is very low. It doesn't mean that it have a zero tensile strength. It has a certain strength, but the capacity is lower as compared to the compressive strength. Now, how we calculate the compressive strength of concrete? You must have performed the test on concrete in second year. So anybody can tell me how we find out the compressive strength of concrete? Students, are you there in the class?
It is
Ma'am,
done
using
using CTM machine.
Using CTM.
Using CTM machine. So somebody will sit inside that machine and will start the machine and will get compressive strength of concrete, right? Is
No,
this the
ma'am.
process?
No, ma'am.
Then tell me the correct process, na?
It is done by casting the cubes of 150 centimeter by 150 centimeter, and then they are placed in the CTM.
Okay. Casting cubes of 150 mm, not centimeter dimension, okay, 15 centimeter or 150 mm cube, and tell me the
The
entire
cubes are
process.
cured for 28 days and then it is tested in the CTM.
Correct, correct, correct. So what kind of force we apply using CTM?
Compressive force.
Compressive force. So axial compression we apply on these cubes, and till we apply the load till failure, and then we find out what is the compressive strength of the cube, right? So how many such cubes we test?
4 to 6.
7 to 6. Okay, okay. Normally in the laboratory for completion of your practicals or just for a demo purpose, we normally cast 3 cubes and we cure it for 28 days. And after 28 days curing, we put it in the CTM machine. We apply the load, axial compression, and we put the load till it fails. And after the failure, whatever is the strength, we calculate as a compressive strength. So though we are casting 3 cubes made of same cement, same aggregates, having the same size aggregate and having a same proportion of all the ingredients of concrete, like cement, aggregate, water, and if we have added certain admixture, then it's proportional also, even though we are not getting the same value for all the 3 cubes. Am I right?
Yes, ma'am.
So if instead of 3 cubes, if you are checking or testing 6 cubes, you will get all 6 different values of compressive strength. This is because of the heterogeneous nature of the concrete. The concrete, the materials used for making a concrete, all are the heterogeneous material. Even though having the same properties, individual properties, still we are getting the different values. And that's why simply by conducting 1 test, 2 tests or 3 tests, we cannot find out a final compressive strength of a concrete or for a specific composition of a concrete. For that, normally we conduct n number of tests. Now, how to define this n? It is normally the n is required is minimum 15 cubes. Okay, so we cast minimum 15 cubes. We test them after 20 days of curing for axial compression. Then we plot a graph, which we normally call as a normal distribution curve. We apply some statistical concepts, and we also apply certain specified acceptance criteria, and then we decide that okay, this is the compressive strength of this particular grade of concrete. Okay, so that particular compressive strength is named as characteristic compressive strength. So simply casting one cube and curing it for 20 days and testing it after 20 days, it does not give you the characteristic compressive strength. We have to cast n number of tests. We have to apply some statistical concepts and some acceptance criteria for n number of test specimens, their results, and then we arrive to a specific value, one value, which we called as characteristic compressive strength. Now, this characteristic compressive strength is very important in the design of structures. We have to deal with this value. So simply by testing 3 cubes and finding the compressive strength is not the appropriate way of defining characteristic compressive strength. So you must be well aware of characteristic compressive strength term. Now, similarly, another important property is the tensile strength. How we find out tensile strength of the concrete? Students?
Under UTM machine.
Tensile strength of concrete. You perform it using UTM? What type of test specimen you have used? Have you performed this test? Have you performed this test?
Not yet.
Not
we
yet.
have performed flexural.
Flexural, okay. You have not performed the split tensile strength. Am I right?
Yes, ma'am. Not performed that.
Okay. Now, tensile strength of concrete, though it is very low as compared to the compressive strength of concrete, we definitely need this value also in the design. So it is calculated in two ways. One is by casting a cylinder having specific dimension, putting it in a horizontal manner, and simply applying a compressive force on that cylinder, so that the cylinder will split into two halves. Okay, this is the indirect method of finding the tensile strength of the concrete. This is the one way. Now, in this method, when we calculate the tensile strength, normally it comes out to be equal to 1/8 to 1/12 of the cube compressive strength. There is a relation between the compressive strength of a concrete and tensile strength of a concrete. This is the one method. In second method, we cast the beam of a concrete and we put it in UTM and we apply a central point load. Actually, there are 3 point loads. The two points are the points where on which the beam is supporting. So these are the support points, and at the center we apply a load. So this is actually called as a 3-point bending test. Sometimes instead of applying a central point load, we apply 2 equidistant loads at the center only. Center means equally spaced from the center. This is called as 4-point bending test. So in both these ways, we actually perform a flexural test of the beam, and we try to calculate again a tensile strength. In this way, the strength or tensile strength we calculate it is called as flexural tensile strength, and it normally has a relation with again compressive strength of the concrete as 0.7 root FCK. Now, in both these ways, we are actually calculating the tensile strength, but the methods are different, and hence the relation between the tensile strength of concrete and compressive strength of concrete is different. And both these we require in the design purpose. Okay, so this is about the tensile strength. Now, we all know that there are many factors which directly have an impact on compressive strength of concrete. See, there are some factors which I can name here, that water cement ratio, aggregate cement ratio, what is the maximum size of aggregate, what is the grading, what is the surface texture of aggregate, what is the shape of the aggregate, again the strength of the aggregates, and also the stiffness of aggregate particles. All these parameters have a direct impact on compressive strength. And the tensile strength of concrete we are deriving in terms of compressive strength. So it also has an impact of all these parameters on the tensile strength also. Now, actually, when we calculate the compressive strength and when we calculate the tensile strength, we are dealing with the behavior of a material. Actually, we are studying how the material behaves under these loadings. When we apply compressive force, when we apply tensile force, how this material behaves. So, to understand the behavior of a material, we normally apply a load on that material and we plot a graph of load versus deformation, right? You must be, you can correlate the same activity with the tension test of steel. In that test, you have done the same thing, that you have applied a load on a steel and you plotted a load versus deformation graph, and ultimately you calculated stress and strain by making use of certain constants, and you plotted the stress strain curve. So stress strain curve are ultimately used to study the behavior of a materials, whether it is a concrete or whether it is a steel. We have to plot the stress strain relation for both these materials separately, and we have to study its behavior. Okay, now for concrete, I don't think that you have conducted this study. Am I right? You have not plotted the stress strain curve for concrete. Am I right?
Yes, ma'am. We haven't performed.
Yes.
Yes.
Yes. Okay. But when we perform the test on a concrete and when we plot a stress strain curve, normally that curve is a non-linear. And for that particular relation, there is an impact of three major factors. The first one is the strength of the concrete and ultimate strain.
How is it, ma'am?
Hello? Are you able to hear me?
Yes, ma'am.
Yes, ma'am.
Okay, okay.
Yes, ma'am.
All right. So the stress strain relation of a concrete is a function of strength of concrete and ultimate strain, the duration of loading, which is ultimately related with creep and shrinkage effect, and rate of loading. So I will go to the first point now. I think we have only 2 to 3 minutes, so I will quickly finish the first part. This is a stress strain curve for any grade of a concrete. Now, if you observe this particular diagram, there are 4 different curves, and all these curves belongs to the different grade of concrete. Now, the grades or these are actually the characteristic compressive strength values which are written in pounds. Okay, so you can observe here as the grade of the concrete or the characteristic strength of concrete goes on increasing, the shape of the stress strain curve also changes. It becomes sharper. For a higher grade concrete, the curve is sharp, and as the grade of the concrete loads down, the curve becomes flatter. Okay, so this is the effect or impact of the strength of the concrete on stress strain behavior. Now, if you observe in all these curves, the ultimate strain value, okay, this is the ultimate point, right? Which shows the maximum stress point. This is the ultimate stress here, and in this curve, this is the ultimate. In this curve, this is the ultimate. So the strain corresponding to ultimate stress, we call it as ultimate strain. And in all these curves, you can observe the value is around 0.002. So whatever is the grade of the concrete, whatever is the shape of the curve, the ultimate strain value we always obtain between 0.001 to 0.003. And this is applicable when we use the axial compression test. Okay, so the ultimate strain value is considered as 0.002 for design purpose. Now, why I'm talking about ultimate strain and not about the stress? We always talk about the strength of beam, strength of slab, strength of column, etc. So we should talk about the stress value, right? And not the strain. But this is not the true concept. Actually, we always deal with the ultimate strain because ultimate strain always represent the failure criteria for any particular structure. Ultimate strain means this is the maximum strain which a particular member can sustain. maximum strain, maximum deformation. Beyond this, we should not go. So there are the limitations put for the strain value and not the stress value. Okay, so in the design also, 0.002 is the particular value which is considered as the ultimate strain for a concrete when it is subjected to axial compression. And when we go for a flexural test, that is under bending, it is considered as 0.035 for the design. Okay, so this is about the strength of the concrete. I should stop now because there are another certain parameters, but I want to discuss all these in detail because this is the basic which you need to understand thoroughly, and then only you will be able to remember all these terms, because 0.002, this value should be completely fit in your brain because this is a basic number which we use for the design. Okay, so I'm going to stop here today, and the remaining parameters we will discuss in the next lecture. I will stop now sharing my screen.